All right. Thank you everyone for your patience, and we're really grateful that you can join us tonight, especially with this horrid weather that's been going on. So welcome officially to the 7th Kubernetes Australia Meetup here tonight at Red Hat on October the 4th and a Wednesday, the first time we'd actually put it on Wednesday. So before we begin, on behalf of the organization, I would just like to quickly acknowledge the traditional lands on which we are meeting tonight and pay our respects to the elders past and present of the Kulin nations and emerging leaders as well. So just a quick rundown of the agenda. We'll be quickly going through this introduction, and before we pass on, I'd just like to also quickly introduce myself. My name is Louisa, and I'm currently studying Bachelor of Commerce and Computer Science at Monash University, and I'm really pleased to be able to continue to help out all of our Kubernetes, Australia, Singapore, and Canada, and hopefully beyond. So for our topics, we will have two amazing presentations lined up, and it's exciting because both of these are run by our very own volunteers. So first topic of the night, we will have Harrison speaking about Linux namespaces. And moving on, we will have Prasanna, who will be speaking about basic RBAC network policy and security context. And towards the end, we will be conducting a raffle / open mic. And as you can see, we have set up here some of the swags in addition to the amazing hats that Red Hat themselves have been able to provide, and followed by a Q&A. And if everyone would like to speak up about any opportunities, job seeking, or roles as well. So just a quick friendly reminder, KSUG is on LinkedIn. Please follow us there if you don't already. There's a QR code to link there, and that's where we regularly post about upcoming events all over the world, as well as updates to when our recording has been posted and related events, such as by the CNCF. Again, it's also on Twitter, just one of our many social media platforms. And a warm thank you to all of our long-term sponsors, including JFrog, CloudCasa, Google Cloud, and the CNCF, for supporting us with all these swags and also just the funds to be able to continue around these community-based events. Of course, thank you deeply to our venue sponsor and long-term sponsor, obviously Red Hat. So they have generously offered up this space again and again. And last but not least, the biggest thank you has to go towards our volunteering team. Several, if not all, are gathered at every event, and tonight you'll see many of them have helped from the beginning to the very end, and hopefully you get to interact with them as well. So thank you to everyone listed here. And as always, we are welcoming more volunteer sponsors and speakers across not just for Australia ones, but if you happen to ever be outside and in our Canada or Singapore spaces to join us in terms of speaking, to sponsoring, or just volunteering as well. So please follow any of these links if you're interested, or come speak to one of our volunteers at the end. So without further ado, these are again just the topics for tonight. And we will start off with Harrison's topic on Linux namespaces. Thank you very much.
So hello everyone, I'm going to be talking about Linux namespaces, which is a vital, fundamental part of, I guess, all the modern container technologies.
Start recording.
Start recording? It says recording there though.
It's recording.
What's up?
Yeah, it's recording.
Okay, should be fine. Okay, technical difficulties aside, quick definition, or basically a quick introduction to who I am. I'm a Red Hat technical support engineer. My area of specialties is Linux kernel networking. Essentially anything that's Linux and kernel related and it's in RHEL, that's pretty much my area of responsibility. Modern typical issues I deal with, more or less configuration, allocation, deal with bugs, and sometimes similar level code level from drivers all the way up to, I guess, the C kernel's TCP stack itself. A lot of interesting stuff, but I guess we'll just go on with this talk. So why am I talking about, I guess, Linux namespaces from in a Kubernetes talk. So the reason is that because Kubernetes borrows very heavily from the existing OS infrastructure. You could say to extent that namespaces itself is actually the fundamental parts which actually makes container technologies possible. So although you technically don't need, I guess, containers or I guess namespaces to actually get Kubernetes working, it is what it's actually modernly, is I guess the modern industry standard to use Linux for a lot of this infrastructure. So let's start with a short definition of what a namespace is. Just keep in mind this presentation will be focusing on only a couple of different namespaces. We're not going to cover all of them. This area is actually really, really huge. But essentially, what I'm planning to do is spread this over into several talks. Eventually, we're going to build a proper functioning container system, which is namespace itself, also C groups. I guess the key point of this slide here is just a basic definition of what a namespace is. In English, this basically says it's a way to abstract resources away from the main Linux operating system and actually separate it into smaller resources that cannot see each other without some specific arrangements. So here's the list of limited namespaces. I guess key point is that all processes within Linux, much of all of these defined. In other cases, we're not using containers. It's usually just a single namespace for all of them. So as you can see, we got things like NewNet, which is a network namespace. We got PRD, process namespaces, and basically also new users, which also is a user namespace. There's a lot of more different other ones in there as well. Eventually, we'll cover all of them and explain what they kind of mean. But today, we're only going to focus on user namespaces, PRD namespaces, and network namespaces. So how do we exactly kind of create and join namespaces? So one key point here I want to make is that all Linux processes must be in a namespace. So essentially, if I could do something like go into a proc system, procfs, and search for a specific process, there's a special file which you can actually access to show you all the namespaces, and that will actually tell you what's already defined. I'll show you what I mean later on, but there's a few ways to leave and join namespaces. ZNS, it basically means to join existing namespace. Unshare essentially allows you to leave a current namespace and join a new one. You can also create namespaces using the clone system call, which is also a flag. I will demonstrate how to do this using C and then eventually high-level bash commands, so you could get a better understanding of what's going on. So here's a very short party trick, I like to call, of basically namespaces in action. What I'm going to do here is I'm going to demonstrate a simple strace on a Podman container. So basically what I'm doing here, what's up? Yeah, I'm working on that. Give me a sec. These things, they take time. Is that big enough for you? Yeah, fair enough. So basically what I'm doing here, I'm doing a simple system call trace, and I'm filtering two system calls. One is unshare and ZNS. And what I'm doing here is I'm running a Podman container with the UBI image. Well, basically it's just a RHEL 9 container, I guess, is the way to put it. So if I do this, this will actually, don't worry about what this is. This will actually filter. Okay, it's not working as usual. So basically what I'm going to do is that grep I on share. Of course it doesn't work. Give me a second. It's not a good demo if, let's say, mess up somewhere. So basically what I want to show here is that the system calls actually be actively called by the operating system to actually create this container. As usual, give me a sec. Okay, so basically that creates the file. So now I'm going to do grep I on share. As you can see, this system calls are actually being functionally used by the operating system or basically Podman itself to actually create separate namespaces. So as I show right now, the operating system itself is actually using them, or basically Podman itself is using them. Set ns, and let's do a ns new, hold on, what's it called? User. Okay, no, I can't find it anymore. But essentially, there's also a clone call, which I want to show you. But basically, this pretty much shows what I want to show you initially anyway. So anyways, moving on from that. We're going to talk about the namespaces in a bit more depth now. So now I'm going to show you how typically namespaces are created using process creation technology. So what we're going to do is just a simple clone call, very standard clone system call, wrap around C. So what we're doing here is that, hold on. So we're essentially calling a clone function, but we're passing in the clone user flag. Basically, what that flag tells the operating system is that, hey, create this process within a new namespace. A few other things I want to mention is that essentially once this clone code gets called, we essentially tell the child function to actually execute the code here, which essentially tells us to get a user ID and get the group ID of this particular user. And furthermore, we want to get the capabilities. So what capabilities means is essentially is a, I guess the way to, we're not going to cover it properly, but essentially it's a way that Linux does permissions in a low level. So what I want to do here is that I'm just going to make the code. I want to show you my user ID and my group ID currently, which is 1000 and 1000. And if I do something like bin clone, and now, as you can see, we created a parent and child process, and we're now we actually have a different user ID and group ID. And let me just keep running this for a while to let you see this is a trick. So yes. So essentially what happened here is that the clone process created two separate processes. One of them is the parent, which is basically created from the bash command, and also one which is child, which is one which created using the clone command. So in the child namespace, we're still the same user, but however, we have a separate group ID. Now, the question you may ask is why this EID and GID is actually very different from our existing group and GID, which is 1000. There's a few things going on here, and we'll try to break them down as quick as we can. So the first things first is that the user 6000 something something something. This is a overflow user. Essentially, what that means is that basically the user ID and group ID isn't defined on this particular namespace. So let me show you what I mean exactly. I will show you a separate. I will start another C program. What this one's going to do is that it's going to use this set ns system call to essentially leave our existing namespace, which is carrying our parent namespace, which is the one which my operating system's on, and going into one which is just created. And after that, we're going to create a bash shell into it. All right. So to make things quick, I'm just going to use pre-existing code. Let's find the PID of the child. And let's enter a bash terminal. So now, as you can see, I'm no longer myself. I'm a user called nobody, which is also known as overflow user. So if I do IDG, IDU, it's now radically different. So why is this the case? First and foremost, if you guys remember from very basic containers, there's a file in proc self GID map and UID map. Now, usually if you do this in a container, it will be defined for you, and that will tell you, what user maps to what particular user in a particular situation. However, as we're using very low-level namespaces, this file isn't defined. So in this case, you have to define this file yourself. And you can think to yourself, oh, essentially we could just, do an echo into this file, right? Surely that will work. No, it doesn't. Because the thing is, the situation right here is that we don't have the permission to actually do that because we're currently a user with no privileges whatsoever. To actually show you what I mean, here's the capabilities, which is all zeros. So if I exit out of this and do this thing again, yeah, which is 0, which is expected. Just give me a sec. Typical. What did I miss? Sudo cat. Oh yeah, excuse me. There we go. As you can see, you have the proper permissions here. Thank you. And basically, we lack the permissions to actually make the changes, and that's why we're not allowed to actually make changes to the file. So if I did this in a proper environment using so basically how we'll actually get these GRD maps, UID maps into the particular namespace. Well, usually this is usually before the clone function. I don't really have time to actually explain how to work it properly, but essentially what you're gonna do is that as a parent, you inject the permission mappings into the what's it called? You inject the permission mappings during process creation. That's the thing you need to get away from it. So that's that. Let me just change it back to this. So I guess I'll quickly just go through what UID and GRD mappings are. So basically what it means is that so usually you get 3 numbers. But if I want to give you a proper example, I'll give you guys one. Cat self cat proc self GRD map and UID map. So basically what this says is that the user within ID of 0 in this namespace maps to the user ID of 0 in the parent namespace up to the length of 4 billion something. So, so for example here, is that let's say in my root namespace, I have user ID of 1000 and I create 2 separate namespaces, each of a mapping of 100, 0, and 2000 and 200, 0, and 2000. What happens is that the effective user ID within this namespace. So if I create a bash terminal, as I showed you guys previously, I'm going to have a user ID of 1100. Likewise, in this namespace here, I'm going to have a user ID of 1200. So hopefully that makes sense. And that's basically user namespaces in a nutshell. In other words, it's a way to kind of abstract user IDs and group IDs away to actually, for namespaces, to abstract, user IDs and group IDs away from the actual overall permission space within the system, which is quite useful. And basically Linux does, most modern containers do it all the time for security reasons, obviously. Okay, so now we're going to quickly just talk about mount namespaces. I'm not going to talk about this currently because this is a huge topic. Mount namespaces actually are used very extensively for virtualization purposes. But essentially what it does is that it actually obfuscate information on a single or separate file systems, either from the container or from the host. Obviously, we're not going to talk about it, but I'm just going to say you could do a lot more than this. So come to the next talks you guys on to, and we'll talk about it. All right. So now quickly, we're going to talk about PRD namespaces. So to expedite the process, now I'm going to show you how you could create namespaces with just simple one-liners. So you don't need to do any C coding. You guys just do this on Bash if you really wanted to. The reason why I showed you the C code is to show you how kind of realistically it's actually done in a programming environment. So to create a namespace, all we need to do is to essentially call the onshared system call. So to show that in action, I'm going to create a process namespace and run a bash terminal inside of it. So it doesn't make a lot of difference, doesn't it? We're still, you don't really feel any difference. Same user, same root, same things, same everything. And you can even say, the PS command shows the same thing. Nothing's abstracted. this is a bit confusing, isn't it? But essentially, it's kind of intended because one thing you need to know is that the process namespace does the abstractions for the processes, but it doesn't obfuscate the mount the proc fs file system. So this is when a mount namespace kind of comes in to essentially obfuscate information for us. So if I do now what I'm going to do is I'm going to show you how that's done. So the only difference is that I added a couple more letters into this unshare command. The key point is that I'm telling the unshare command to actually mount a separate procfs instance. So what happens here is that essentially this is going to create a fully isolated process environment that we could use. So if I do that, if I do psaux, as you can see, we don't really have all that noise anymore. So basically we had a PID of 1, which is usually a unique process, but in the case because we're in a container, it's just a bash terminal because this is the only process running this particular thing. So now you can see how powerful this is to actually obfuscate information from the parent or potentially separate namespaces, allowing us to have that behavior of process abstraction or separation between certain things. The diagram here kind of shows the same thing. So as you can see right here, this is a root process and creates a bunch of child processes. Once we create a child PID, it still has a parent PID, but if we're doing anything inside a namespace as we did previously, so for example, launching a bash terminal, only thing we're going to see is the PID of 1, 2, and 3. We're not going to see the actual parent PIDs. So now we're going to go to the, I guess, the most important part of this presentation, which is network namespaces. Network namespaces is a key way of basically how things can communicate between separate systems. So what it isolates essentially isolates most of the TCP/IP and basically networking stack in Linux. So you can think of things like interfaces, devices, IPv4, IPv6 protocols, IP routing, and even firewall rules. So you can essentially have mini VMs by just playing around with network namespaces to an extent. Now I'm going to demonstrate how to actually play around with network namespaces. So I got a basic system diagram here. In traditional container networking or stock standard ones, basically we have essentially what we're going to do is that we usually have a bridge in the parent namespace or the host of the containers. And essentially what happens is that we're going to have virtual interfaces, which allows us to connect everything together. So for example, if NS1 wants to talk NS2, we'll go through the virtual Ethernet connect to the host, into the bridge, and towards the other network namespace. Today, I'm going to demonstrate a very simple abstraction of that. So basically, we're going to create a direct link between two different namespaces. So now let's get my terminal out. Clear. So because NetNS is like a very huge area, we have our own special commands for that. So to create a simple namespace, all we need to do is just IP netns add client, or basically whatever you want to call a namespace. Keep in mind when doing this as a root user because network namespaces are usually require these permissions. There are cases we could get away with some of them, but usually you need root permissions for all of these. As you can see, it's not playing nice because I'm not in the proper namespace. Yeah. Clear. Yeah. So I previously done this already, so this is why it's telling me files already exist. So I created two namespaces currently, and each of them are I guess one of them is called client and one of them is called server. These are network namespaces. And so if I do an IPNetNS list over here, we'll see there's a server and a client. Okay, that's not supposed to happen. Just let me try something. Give me a sec. There we go, much nicer. So now what I'm going to do is that I'm going to show you what we see inside a particular namespace. So what I'm going to write here is just IPAD. That's a simple IP address command. And basically, as you can see, we only have a loopback device, which is expected. So I could do this for the client as well. I typed something wrong. That's odd. Okay. Don't worry about that. I'll figure it out eventually. So if I do RPAD here, it shows you, the existing, I guess, internet devices. But if I do something like server, this shows basically what's in the namespace. So you can see there's definitely a difference. So now what we're going to do is that we're going to create 2 virtual Ethernet devices currently. So a virtual Ethernet device, you could just think of as an Ethernet device, but virtual. So that's what I say to think about it. So if I do an IPAD, you can see I created 2 virtual devices right here. What I'm going to do right now is I'm going to send these virtual Ethernet devices into the separate namespaces. Why is it giving me that? Excuse me, it's not playing nice again. As you can see, this doing things at this low level abstraction is actually quite dangerous because there's not a lot of safety rules. So if you mess something up, you get error messages. You actually didn't even get error message. You get something that's very unhelpful. Anyways, where were we? So if we, let me just double check if I did my correct work. Yeah, so everything looks good to me. So now what we're gonna do is that we're gonna associate the interfaces we created previously with a with the essentially with the server and the client. Give me a sec. PDP client. All right. Don't want to play nice. Okay. Okay, let me just double check if I did everything correctly. Okay. So you can see, I see what I did wrong. Just give me 1 moment. All right. Bear with me. I'm gonna do this again, but with a separate list of instructions. I'll be back. Okay. Bear with me. Guess the system isn't playing nice today. So what I'm going to do here is just going to quickly enter some environment variables, which is essentially the same thing I did before, but I guess I missed something while I was doing this, and it's not working anymore. Where is the bloody terminal? There it is. So we're going to quickly do the same thing again. You guys already seen this, so I'm just going to quickly go through it. Add server, that's expected. So as you can see, yada yada yada, that works. So we're going to do this again. So once again, we're just looking at the server namespace, and let's have a look at the client namespace. As I said previously, we're going to add the separate interfaces. So if I do this, you can actually see the virtual infinite interfaces here. And now we're going to associate each of the interfaces with the namespaces we created. So for example, the client and the server. And basically what we're going to do here is that we're going to show you what the server namespace currently looks like. So as you can see, we moved the virtual infinite device into the server namespace. So basically the one belonging to the server. I could do this for a client as well. And that works as expected. So one thing is that we don't have any routes currently, so I'm going to add the routes. So if I do this again, we should have a proper IP address assigned to this as well. So now we could bring up the two interfaces because it's currently still down, because state down, that's shown here. So now both interfaces are up. Let's confirm that. Let's look at the client. As you can see, it's state up currently. And let's look at the server. State up as well. So now what I'm going to do is I'm going to run a very simple Python server. And I'm going to quickly create a separate terminal. Give me a second. And I'm going to curl at that particular. I'm going to send a simple curl command. Let me just make this big off so everyone can see. As you can see, we have things going on right here. So we're curling and we're getting a bunch of random shenanigans out. But if I do this without a namespace, so I do it in the parent namespace, or basically the main namespace that gets created, or basically belonging to the bash shell currently, it doesn't work. So that kind of shows you how we could kind of obfuscate information using network namespaces. And that's essentially what we kind of did right here. We created a direct link between network namespace 1 and network namespace 2, and we bypassed network namespace 3, which is the host. Other than that, we've gone through some very basic concepts that could be used to make a namespace. The next logical step is to combine everything together. In the next few talks, I'll slowly start building on this kind of knowledge. So we're going to talk about mount namespaces, C groups, and eventually we'll make a very basic container, I guess, containerization device. That's the presentation. Any other questions? Or we're good?
Docker or Hot. Because probably they might be doing this thing to actually get a container.
I know they used to do it like a very long time ago.
But
Yeah.
It's good. Thanks.
Was this stuff added to the kernel recently?
No, it's been around since 2002.
Oh, okay, right.
Yeah.
So this wasn't made with containers
So
in mind.
containers
wasn't.
are from 1980s.
You could
Linux added from Linux has this basically, if you remember, the first commercial product for containerization was released by Solaris in 2004, and Google was using containers by then. So containers were there, but Docker made it accessible to everyone.
I think in Linux, Google added them as part of developing Android.
Yeah.
So I think Android makes heavy use of namespaces as well.
That is correct.
I have a question for Harrison.
Oh no.
From the host environment that you were doing the net namespace stuff in, if you run IP address, like do those interfaces you've made still show up at the host level?
No, it doesn't. So it's completely gone.
So as soon as you change the net namespace, they actually disappear.
You can't see it from the host. I mean, if you could by doing some running crazy hacks in a procfs file system, but it's not possible.
So is that because normally you start in some default namespace?
Yeah, that's correct.
And so there's not necessarily a root one or a tree of them. They're just arbitrary named ones.
Yes. I guess that's the way to look at it. So I guess way to say your question is that once it's assigned to a separate namespace, that network device is gone. The hardware device will be still there, but keep in mind it's abstraction between virtual devices and hardware devices. You can still see the hardware device by using let's say going to sys/dev, and you can still ping the device that way, but to actually access it using the software, it's not possible anymore. Yeah, so you had to go into that specific namespace to actually access the device. Yeah.
So what happens to the file system with the process namespace?
So you're talking about when I did the mount thing, right?
Yeah.
So basically what happens is that they created a separate instance of the proc namespace, well, basically the proc file system. So you know what a proc file system is roughly, right? Or do you want me to explain it? So a proc file system is a pseudo file system within Linux. So basically it contains all the information, I guess, that's available at the application level from the kernel. So basically, let me show you an example of what I mean. So it doesn't exist. It's standard with all kernel operating systems, or Linux operating systems. But the thing is just like, it's not exactly a file system, but something that actually exists only in runtime. So if I do proc fs, you can see a bunch of numbers. This is just all the separate processes. Basically, what the mount namespace does is create a separate instance of that. And no, it isn't a copy. It's a completely separate thing. And basically, what happens is that the parent theoretically could still see the child, but the child cannot see anything in the parent namespace. So that's a way to look at it. I'll explain this later on when I get a time to actually talk about this. But this is why I don't want to talk about mount namespaces, because it gets really complicated later on. Another things you could do is that you could look at statistics. Let me just do proc VM stat. So it's just a bunch of VM statistics I could talk about. There's crap tons of stuff in there. It's pretty much on all the stuff that a kernel kind of exposes to the application level that you're allowed to access. But anyways, that's pretty much what it is in a nutshell.
If you just run the mount command to show your mounts, you'll see. Then it just
it's the same thing. This is the wrappers for the mount. It kind of wraps around this.
The first line actually, the proc thing is saying that there is a proc file system mounted at /proc.
Mm.
And when you start working with whatever namespace it is that does it, as part of mounting it, it shows you a particular namespace, right?
I don't know the specifics of it. It's a bit complicated. Documentation is scarce.
The /proc mount is mounted to different procfs that is in the namespace. So when you look in there, you won't only see what's inside the sub namespace. So,
Kind of segregates, it creates its own temporary containerized version of proc environment rather than the host proc directly referencing directly.
yeah, I don't know how specifically it works, but it's probably
Usually you use runc to actually create those environments, right? So what happens is host operating system usually pushes a copy of runC in the proc environment of the container, and then that particular runC executes all the commands to create your container, and then it gets. So you don't expose the real version of runC. That restricts the risk of contamination of your actual runC executable on your host environment. So that's why it's more of like a copy which has been created inside the root container, and that gets executed. Also, just a small check: do the /mount space namespace actually is used for chroot jailing? Chroot jailing.
What is, sorry?
So chroot jailing is just a temporary namespace with temporary file system that a container gets when it's created. Rather.
Yeah, I don't think I'm familiar with that. I'm a Nix person. I'm not particularly big into. Well, I am supposed to be big into containers, but I'm not that familiar with that, unfortunately. Yeah.
chroot just changes what particular folder the root
It's
wants
the
to
Wait,
install.
chroot?
chroot chain is the
chroot,
process
yeah.
of just restricting the container's capability to see outside the basically to the host operating system file system.
Are you talking about chroot?
Yeah.
Chroot. Okay, that
Chroot
thing.
is the
Yeah.
process where we can change the root of the file system.
It's completely separate to what namespaces are. Different, kind of similar ideas, but kind of different methods of function. That's why I put it. Any other questions before I hand it off? Okay, well, good. Thank you very much, and I'll be handing it off to Prasanna to talk about his stuff.
Thank you. All right, so let's start with some basics. I'm pretty sure like most of you know this, or maybe I'm just guessing it out. The idea of this session is mainly to touch upon basic concepts with the Kubernetes network policies and security context and role-based access controls. Because I still remember, even after 2 years of my journey in the Kubernetes, I gave an interview, and all of a sudden, like the question I was asked, like, how do you secure the pod? Okay, that's kind of with the Azure AAD that time, and also the how do you control the traffic between the like pods? This question I could not answer it basically. One of the main reasons is like yeah, this thing I always used to like postpone, or maybe like I never encountered in the situation where I need to learn those stuffs. Then I realized, okay, there is other areas which I need to be aware of the Kubernetes, which is apart from the regular API development services, all those things. That's when I started looking into the administration section of the Kubernetes. And I loved that the whole, the model and everything. It's so cool. So that is the brainchild of me to just give it a thought of my understanding, and it could benefit if somebody of you not come across this kind of this particular topics or haven't read this before, then it's definitely it's going to be a kind of a help for you guys. So let's dive into this. So when it comes to the security, I'm pretty sure it is a big, like swimming in the open ocean. A lot of stuffs are there, but I'm going to cover basic like network policy, RBAC, and security context, which is very much rudimentary. Okay. So what is the difference? At first, we see like we have 3 players here: RBAC and the network policy, security context. What's the difference, and why they are there like in a different spots? Why can't we they are like together? So basically, RBAC is like who can do what. It's like controlling the access of the API groups, and so that the subjects like users, groups, and the service accounts, they get they get the like privileged access to those API groups. I'm sure like you guys know what is an API group is. API group is whole Kubernetes ecosystem is controlled by the set of APIs, and those APIs are like grouped into relative to their segment of kind of the work they do, like core API groups, networking, authorizations, secrets. They're all categorized into different API groups. So we use RBAC to control the access to those resource groups for the different set of users and groups and the service accounts. That's why the RBAC is there, and that is the it solves a different area of problem solving. But network policies is again another area wherein we will have to control the traffics between the pods and between the namespace to namespace, ingress, egress. This is when the network policies comes in, which the RBAC can't really achieve it. And that's why these network policies are there. That is the scope of the network policies. And then comes the security context, which is again another interesting stuff, which is the scope itself is limited to the pods or the like container runtimes, wherein we control access to the underlying host resources, like the nodes basically. So wherein we will say that, okay, hey, you can't run as an administrator or like root user, wherein we want you to run under some sort of some sort of users, user IDs, group IDs like that. So this is where the security context gets into the picture. So let's dive a little bit more into the what is an RBAC it is. With the RBAC, we got options. The options is like, do we want RBAC to be applied upon the namespaces, or do we want it to be cluster wide? This is where the Kubernetes has the two entities called roles and role bindings, wherein roles defines the actual resources verbs we want to control, which I'm going to show it in the next slide. Like get, list, watch, create, delete. These are the one of the verbs for the pods, which lies under core API groups. Once we define these roles, then we use the bindings of the Kubernetes another manifest, where we define which subjects we want to link these particular roles to. That's when we say like whether I want to group to the user or to the group or the service accounts. This is how this role and role binding comes together to form a kind of an role-based access control for the user. One of the main question I used to always ask, like, hey, I always, when I install a Kubernetes out of the box, like any of like maybe micro K8S or something, I never entered any usernames. Like when I say gives me the Kubernetes context and I just log in and that's it. Where does comes the users then? Where is the and most of you might have wondered, like this is one of the question I always ask, where is the user? And then I thought like, oh, there is no concept of user. Maybe it's something like fancy term. So that's changed when I started to get into this deployments into the cloud basically. Okay, sorry, yes, I have to share the screen. Oh. Sorry, just I'm sharing the screen. Okay. Okay, yeah. Oh. Yeah, yeah. Right. Thank you. So that is one of interesting question to me always. Like, so then I dig ChatGPT before even ChatGPT. I digged into that. Okay, I started asking lots of questions to the ChatGPT itself. But before that, so then I discovered, okay, we need to attach a certificate when we use a Kubernetes context. I'm sure pretty much of you know, at least one or two people. If doesn't know it, then means I am safe. Like, so this is how like we associate users or a group or a service. Yeah, service account is again, it's straightforward. User or group is with the help of the certificates. That's how the we said, okay, this right now I'm logging to the Kubernetes under this user and under this user and under this user, like this. That's how we used to say. So that's when we can say that, okay, I am when we log into this user, this is the role and role binding attached to the users, and this is how that this particular user have the access to this set of list of resources or not. This is for the namespace specific. But if you want to go to the cluster wide, that's when we have to have the in the place of role, it's called cluster role. In the place of role binding, that becomes the cluster role binding. Then pretty much that rest of the definitions remains the same. I guess most of you guys know these concepts, or anybody else? Is this the first time, guys, you have going through these concepts? Anyone? That's okay. Let's go to the next topic. So, where is the use case? Again, the one I mentioned is like yes, but in real term, like most of the situations, like each environments will have its own clusters, like prod, dev, test, UAT. They have their own different clusters. But there could be like multi-tenant scenarios wherein we use one single cluster and we separate the resources for each development, testing, UAT, and prod. Just to cut down the cost and the rest of the stuffs, and still we want to achieve that the development team doesn't consume all the resources into the other allocated for the other resources, other teams. This is when we can use RBAC to control all those kind of aspects. That is one of the classic use cases, but there are lots of use cases out there. Okay, network policies. This is quite interesting also. The difference here, it is like from RBAC. RBAC is with the access controls to the resources, whereas here it is like traffic controlling, like how we control every firewalls. Typically in firewall, we use to control the traffic, whether packet can reach to this destination or it can come from this destination. The same kind of activities is done by the network policies. And what are the key players of the network policies? The selectors, match labels, ingress from, and ingress to. These three parameters actually control the whole communication between whether to pod or from namespace to the pod, or whatever the traffic can go from this pod to the outside, or whatever the traffic can come from the another namespace to this. These are controlled through this network policy space. This is how the YAML literally looks like for a typical network policy thing, where we say we need like policy types. Most of the time we hear that Kubernetes is highly insecure by default. That means Kubernetes really insecure. So we need to go and change a lot of. First is like zero. Drill down to the point that access to no access to anything and everything, and we give the access only when we need. Okay, this pod wants to communicate to this pod. All kind of the minute details of things starts to happen from here. This is the place. I haven't put all those things here. I'm just briefing it out so that it gets just a heads up on like how this thing looks like in general. So pod selector is something where I say like match this label like example-app. That means any ingress originating from these pods is acceptable for the namespace under which this is policy is running, and anything else, it is not acceptable at all. That is how the control happens. Same way, the namespace selector, it says the traffic can only originate from the namespace that is called example project. Any other traffic comes from any other namespace, that is straight away it is going to be declined. That is a kind of a nice security actually in itself. Then IP block, there is another CIDR block. Same in this range, any traffic comes, it is accepted. If it does not, then it is takedown. With the exception rules, we can put it forward. Egress is another interesting stuff. Basically, smart theft is one of the key thing wherein something from internal, the data goes outside. Wherein that is one of the latest new age challenging threats in terms of cyber security, wherein this is the place where we can control that, one of the area, the egress things. So where this traffic from this particular port selector, where the traffic can go outside, that controlling happens here. As I said, I am not going to go into the broader side of the security aspects. It's way too bigger, and it's way too bigger, and it's totally easy to get lost. Like it's like swimming in the open ocean where we don't see any shores in the. It's like that. Yeah.
What is the wildcard? Like, for example, I'm from cyberspace. So if let's say I'm reviewing the config of this one, what is the red flags that I should be looking out for if it's overexpensive?
Yeah. So from the egress, yeah, we can put the wildcard actually, but yeah.
You should be looking at the dash at box number 2, because this will say from namespace or from pod. If you want to do pods from the namespace, like end, this needs to be in the same clause. You know what I mean?
Yeah, I mean, like from the.
You have 3 separate entries here.
Yes, yeah.
Which are odd.
Yeah.
So if you want from specific pod and specific namespace, then you need to end between them.
Yeah. I mean, like this is for like just to show that all the placeholders available.
To look out, this is very common mistake, and this is the Kubernetes document calls this out. You need to be very careful about these dashes because it's difference between and or.
So dash is an or?
Here's 3 different entries, so it will allow from these or these or these.
One or two.
But usually you want to say from deployment in this namespace. It's like in real environment, I don't think you want to be like from whatever pods, as long as it has this label, you can talk to it.
I think the dash is it's array syntax in YAML. So what it's saying there is that there is an array, the value under 2 is an array of 3 with 3 entries. That sounds like by default an array of entries is or in Kubernetes config.
Yes, and then in the network policy.
Is there a syntax for handing them together?
You'll just leave out the dashes. So you only have the first dash on the first one, and then if you leave out the other dashes, then you've got an array with a single element, and you're saying this policy only matches if you have the pod selector and the namespace selector.
Oh, sure.
Yes.
So you can have the pod selector and namespace selector keys in one object, and then that counts as handing. Yeah, that makes sense.
So under that namespace, in that pod, if matches with that tag, that means that is acceptable. And it's additive. These clauses are additive in nature. They are not exclusive, like they add upon, like there is no and, they are not and, they are like additive.
So there is no or actually. Every particular case that we add keeps on adding to your. It's like firewall, like it keeps on adding the rules to your access list.
Yes.
And if you want to specifically deny, there is an option to deny rather than allow. You can use that as a to actually deny rather than if you want to use.
How do you deny? Deny network policy?
Yes.
How do you deny network policy?
You can actually,
yes.
if I remember correctly, if there's an option, I can't exactly recall right now, but you can exactly add that particular, you can just basically how it works is the whitelisting part.
Yeah.
So you just specifically whitelist these are the tags and these are the CIDR or specific namespace that is where you want to allow the
Only
traffic.
allow in networking that maybe in things like Cilium or Caliph or
Mhm.
whatever, but in native Kubernetes,
Yes.
Yeah,
there is no deny.
No, it's not. I'm specifically looking for Cilium because I have been working with Cilium.
Yeah.
And you can use network editor. Basically, it's an online network editor, network policy editor, which allows you to create policy depending on your namespaces. And you can actually use them to actually review the policies as well, adding directly to the network editor policy.
Yeah.
There is something, if you can show
Yeah.
the network editor policy.
Yeah, this is one of the deny all basically.
Yeah.
So here in Kubernetes documentation network policies, they cover like couple of use cases. Like this is entirely deny all for all the egresses, and if it is has to be for everything, then allow all egress different scenarios. We just can manipulate. Sorry, I mean like play around here to mix and match the exact use case we want to achieve this.
Yeah, so network policy, native network policy in Kubernetes, it's only allow. What happens here is that I allow ingress,
Yeah.
but to nothing. Like you basically give empty rule set for ingress or egress. This is how this deny works. But in native Kubernetes, you can't say I deny communication from here to here.
We can.
Well, then we can check out.
Yeah. So this is what is this point actually? This one. What do you think of this?
So this.
You can deny, like there is no keyword deny.
Yeah. There is no dig in a
You
keyword deny. No,
can't
sorry.
say I
Yes.
deny explicitly from this to this.
Yeah.
So this network policy, what it means, it selects everything because the port selector is empty, but you don't allow anything, and this is how it denies.
Yeah. Yes, that's true. Selective wise, we can we have to compose it very much granular level, and that is use case like case by cases. Yeah. Maybe. Yeah. That's. We can explore on that maybe in further in next sessions, like in depth of the possibilities with respect to the Kubernetes deny things. Yeah, that is a good topic to discuss basically. So this is about that, and then okay, let's go to the next one. Okay, I think we pretty much covered here. I'm going to skip this, but I'll just point it out like yeah, okay. So this is one of the use case scenarios, but we just spoke about the more details use case scenario where you guys have asking the question. A front-end service should access a database service, but not other internal services. This is when this kind of one of the use case scenario. That's when we need to consider network policies in this, because we can't achieve with the RBAC or security context because they solve the different purposes. This is the use case for this problem statement. This is the solution to go forward. Next is about the security context. Yeah, as the name, this is like very much limited to the pods and the container level. It doesn't go beyond, unlike the RBAC and the network policies, it doesn't go to that extent. The perimeter surface area is very limited. And this is about controlling as run as users, like a run as group, thereby limiting access to the underlying devices, and all Linux related, all OS related checks we can control through the security context, and that is the main idea of that security context as such. Yeah, that is the thing. Yeah. So, questions?
Question about the permissions in a role. Does the application have to check those permissions, or is there something else that enforces those permissions?
It is Kubernetes.
the list permission, for example,
Yeah.
if you apply that role or you bind it to a pod,
Yeah.
that pod can only list something in another.
Yeah.
Is that how it works?
Yeah. So the Kubernetes takes care of the permission checks. Application do not have any control over it. Once we set up these policies and once we deploy that manifest file, that means we giving control to Kubernetes, and Kubernetes does all the traffic checks and access control checks. Everything it takes care of it. It takes care of it.
Okay, those permissions, are they application specific permissions or are they something?
No, they're specific to the API of Kubernetes.
Kubernetes, yeah.
So when you, even if you have a service account and you give them RBAC, it's just to access this API.
Oh, okay.
Yeah, also when you create the pods, there will be a service account attached to the pod.
Yeah.
And there'll be a, I think there'll be a token mounted inside the pod as well.
Yeah,
Yeah. So when your application need to communicate with the API server, need to use the token that in the pod system as a directory consolidation directory.
Okay.
Okay. So yeah, that is the. Maybe I should have covered a little bit more topics. I thought like it's going to take some time, but so there is other aspect like maybe I should have brought it with the Azure AD integrations. I wanted to separate this one totally because this is very native to the Kubernetes. I didn't want to attach anything related to any cloud specific providers because moment I do that, then also AD, Azure AD, then AWS and GCP, they all go different and then it gets mixed matchup. Yeah.
The users mentioned in the first part, role-based stuff, like the usernames. Where does that list of possible usernames come from? Are they defined? I'm not really familiar with Kubernetes specifically.
Yeah.
So does Kubernetes have its own database of usernames?
Yeah, nice question actually. I wanted this question.
Or are they usernames on the Linux host?
Yeah, that's a good question. So this is what exactly these certificates do. When we out of the box, like when we install vanilla Kubernetes or any of those in local machines, we don't even experience it because it logs in as a root user. We never get an option to say that, okay, I'm logging with this user. That's when, as me also I had, this is basically, we supply in the form of a certificate to the context we create.
Is it a TLS client certificate?
Yes.
Yeah.
Exactly. Yeah. Yes. 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 Exactly. Yes.
That certificate has to be signed by the Kubernetes CIO, right?
Yes.
Is
Yes.
there tooling for that?
Yes, there is a tooling for that. Yeah,
So
there is.
so if you have the root context, you can talk to it. Is that the Kubernetes API function to say, please send me a new certificate for a user?
Yes. In this case, like you suppose if it's a cloud provider or anything, the main root user has to issue the certificate to the client with the name, email ID or name or anything. There is a tool. Kubernetes provides the ways. Vanilla Kubernetes also provides the ways to create the certificate. Cloud providers also they do it by without much of us to knowing that automatically they do it based upon the kind of the login we are right now. Like example, if you are in Azure, then if I want to import the Kubernetes context for that Azure cloud, sorry AKS, then my current email ID will be username, and that will be issued, and certification comes and downloaded to my account local, and then the context itself will be attached to that certificate, which generally used to log in back into the Kubernetes cluster. Thereby, we get to control which resources we can talk back. All those things happens there. That is Yes. Probably I should have brought that up point next in the future meetups. I'll go in depth of that. That's a cool question.
Yeah, I would be very interested to see the bootstrapping for that. Like, you need a CA certificate, right? And how is the CA certificate created if you set up a Kubernetes cluster from scratch?
It's done for you.
Sorry?
It creates its own CA, and I think they keep the key inside the LCD, and you don't have access to it. It's only Kubernetes which is able to sign when you create a new user, it creates the certificate and give you the signed certificate. But there's other way to authenticate on Kubernetes. So you can configure this with an OIDC provider, and then you just do a matching on your email address or whatever the attributes you're claiming.
Yeah. That's cool. I always fear of security, guys. Security is meeting. When I say something is security, that it's like putting me in a like boxing bag and somebody's boxing me. Yeah. So
Once you do a talk on security,
yeah,
I guess that would be a good talk, because that's kind of a subject that comes.
yeah,
I see two people that are kind of experts in there or have
yeah,
quite a good knowledge.
yes, yeah.
If you want to just sign on the next slide and volunteer to do a speech, that would
Wow,
be good.
that's cool. So yeah, next one of the sessions we can put that on security aspects, like yeah, couple of challenges the security. Yeah.
For us, security folks, right? Like we are interested in knowing what kind of misconfigurations that developers usually make, which is why my initial questions.
Yeah.
And then also like how to fix it, because like a lot of the times developers, for example, in the namespace stuff today, they're like, oh, this is handy, this is convenient. But for us, like from the red team or offensive side, we always think like, how do I find that you have this? How do I break out of this? What could go wrong? Like, how can I bypass it? What kind of misconfiguration that will give me, like, for example, container breakout? Because that's essentially what is the blind spots of what the developer side of things usually are.
Yeah, that's a nice.
Visualization tools.
I can't remember that there's one, I can't remember the name from the top of my head, but there's one which just scans, so you log with the admin and scans your cluster and says, this is bad, this is bad, this is bad, and by default there's a lot of bad. So there's probably 900 lines of bad things to do.
That took a Kuberbench.
Yeah, there's a bunch of tools, probably this one, I can't remember.
Yeah, there's a lot of GitHubs, like auto scanning your YAML code, like to pick up what misconfiguration. For example, in the security context, there are two settings, or actually two settings you have to run as a non-root. They both have to be enabled as true, because otherwise, if the other one you set as a false, then that's where the gap is. So those kind of little things that security folks like us probably would be interested in.
Wow. I'm sure we got a next deep meetup for this. I'm sure. Yeah, I guess this is a good point to cover. It's like good to know like what the community is interested in, and then on that basis to fine tune those meetups. It's a very good.
There was a guy who did one of the previous meetups. It was at the Google office, and I was talking to him, and he was talking about he was very clearly like a very security minded kind of person. Like it's one of those people, and he's talking about the tool Shodan, which is a public internet port scanner, or it's like a search engine to open ports. And he said in his spare time he was searching through I don't know what port by default Kubernetes API servers run on. 6443. He was just scanning IPs. I think he scanned all IPs in China for open things and found way more JSON coming
Probably is searching for port number 105,255.
Yeah, but it's just like, yeah, it's like just set up a loop.
Yeah.
Send the traffic.
It's a read-only kubelet post, which actually, if you just connect to it without any credential, it will split out bunch of JSON for you. It's fun.
You can spot security people sometimes.
So just to, with this problem about exposing the Kubernetes API, to avoid that, you typically only access it within a VPN. Is that the?
Yeah, and or if you really needed to make it public, like just want to ultra check what authentication is allowed on it, probably.
Fun part, the most of your cloud providers actually expose your API server over the internet. Have fun.
So how you guys are utilizing the ChatGPT for Kubernetes? I'm serious. I'm asking every question. The toughest question which I can't answer in the Google generally, I'm getting answered in the ChatGPT to the finest implementation level to make it like literally like I ask like multi-tenancy oriented questions as much tough as possible. It clearly helped me out like to the core. It can take that question. I'm astoundingly, I'm surprised actually. I can't just answer, get that kind of answer in the Googling, just simply either reading the documentation.
You screen record your chat GPT interactions because it's non-deterministic. And then when you go and try and show your supervisor, look what I found out, you do the same thing and get a completely different result.
That is true.
Because I remember, I remember at times when I did research and I came up with these great links and then I listed them in my paper. I had all the sightings and my professor said I couldn't get any of that. And it could have just been that that day the security firewall in Cuba or wherever was down. And so I was getting links to resources that weren't available.
That is unfortunate.
But non-repeatable results is the big worry about.
Yes, that happens a lot. Even me.
So how do you, what I'm asking is, how do you document your process when you use ChatGPT? No, but I mean, no, you can't.
The thing is, so the thing about that is something all large text models and probably anything else that does inference on machine learning models has something called a temperature.
Yes.
And temperature is basically how much just randomness it just adds into your query. So what you need to do if you want to avoid this is you need to run your own inference and you need to set temperature to 0 on your own inference.
Right, I understand what you're saying. What I mean is that knowing that you've done it, and then that when you turn around, I can't show it to you. How do you document that you actually did the thing and got that result by doing the thing?
Yeah.
Do you set up a video camera behind it?
Yeah, one
To actually record the results of your query, knowing that the next time you perform the same process, you might get something different.
Yeah, different. One way is like we always can use that prompt, you link, share it because the link is like quite shareable, like public. The whatever the queries we get it, and that query is shareable to across. That's called nowadays called prompt engineering in the ChatGPTs. But still the answers varies. It does not give the same answer each time. Even if I run the same query, it just second time it gives me the different one. It's that is the as long as like what the intended answer we want to get it, like as long as it solves as long as it becomes our solution architect or a security architect, it does that job for it is doing it. That means we get the most out of it. But documentation is like something it's highly unreliable. Yeah, but it is helpful because the same questions, even if I want to do it by asking, like I need to ask like where is our expert, and then they have to go through the answers, and then we need to tally upon. But this is giving out of with great models and output results from the I don't know. So it is very accurate and it's so clean, and that is one reason like I mostly use ChatGPT. I forget Google also. Actually, nowadays.
I have searched one time. I just checked. I had some issue related to
I asked ChatGPT, it gave 5 options, and I tried all the 5 options, it didn't work. This is my experience most of the time, because only it works is your experience.
Yeah.
My own experience. The last time, if I did the same thing, how it solved. So, according to my experience,
ChatGPT is not reliable. It happened to me once. Google Map.
Lot of options.
Yeah.
If you try all the options, it will take on different direction.
Yeah.
Oh, yeah.
But of course, for basic troubleshooting, I mean, it's good. You will have good pointer
Yeah.
where to go.
Yeah.
But for advanced troubleshooting, I think it's not
Reliable.
not
Yeah.
reliable.
I had some fun. I've been working on some payment processing stuff recently, and the definitions of how stuff work are in paid specifications, like ANSI standards that are not online, other than behind a store that you can pay things for.
Yeah.
I tried asking it some questions about things like key size or whatever. It was just completely wrong, and I said, "No, that's incorrect. You've told me the old answer. What's the new one?" And it gave me a different wrong answer.
Yeah.
If that is the case, then we don't everything ChatGPT will do. Why, as a human?
I think it's
Yeah.
good for,
Yeah.
I treat it as like it's good for simple and boilerplate things.
Yeah.
If it's something you'd find, because the majority of it was trained off the internet, right? So it's
Everything
like
might be coming from
if it's
Stack
something you would
Overflow.
find in a tutorial, if it's
Yeah.
something that you would expect would be something you could obviously find in a tutorial, but you just need a particular phrasing or something like that. It'll probably get it right. But I wouldn't trust it to get specific questions right.
Yeah.
So treat it like a room full of like junior employees. Like a bunch of them will have random facts that they'll throw at you.
Yeah.
It might help you brainstorm to like go and do proper googling.
Yeah.
That's about it.
Yeah.
It does like that. I think
Maybe like if you put proper prompt, you might.
Yes. Yes. Yeah.
Maybe I have to invest better prompt in it.
Yeah.
Ask it
Exactly.
Ask it for citations. Say, oh, well, tell me this. What section of the Kubernetes documentation should I look at? And see if it gives you a link.
Yeah.
It will give you the older link.
That is another challenge.
2021, I guess, right?
Oh, yeah. Well, not with the news.
If you paid for that.
You can ask Bart.
Yep.
Yeah.
Anyone from Microsoft? Dave?
Yeah, let's not disappoint them. I know. He's going to disappoint it. If anybody is from Microsoft, then please close your ears. Bard is my experience with Bard is no, it's never.
I kind of use all of them together to see which fits my requirement. But
yeah, it's just like a Google.
It's not a deterministic thing.
Yes.
It's more of a reference. Then you kind of take that answer, start working on it, and see, validate it if it's worked or not, and then probably use it in your environment.
Yeah. Yeah.
I'm reminded of in my primary school time when it was like Ask Jeeves and Google and all these different search engines. There was a search engine called Dogpile, and all it did was search on all the other search engines and then aggregate them all into one set of results for you.
Right, so then it'll be which order to go Bard first. Then
Yeah. Six possible. It's like asking a panel of candidates or executives.
What's your opinion on this?
Yeah. The voice.
So that means let's get some. What is the?
Trying to get back to PowerPoint.
Yeah.
There's at the end of this page. Thank you, Prasanna, for that second topic. Really engaging at the end. Now, as mentioned earlier, we would really appreciate it if you take just a few minutes to fill out our feedback form through the QR code. It will really help us improve each time. And with that, you also enter into the raffle for these awesome swags. Okay, you get good to do all that. I might leave. Do you know actually what you get Susan to do? Yeah, I'll just show you. She can show you. Yeah. Okay. So you're leaving now. Yeah. So you go to the phone and then go ahead. Yeah, okay. Susan, here we go. Susan, you wanna ask? Okay. You can do that actually. Just refresh. It's like what's on today. Into the field. It's Mac out to fresh Mac. No, come here. Just wait for this person and then grab the name for you. Yeah. Just refresh. Still waiting. Yeah. I think this one. Yeah. Where is the yeah. So somebody's going to everyone can take the stickers. Yeah, just save it for the next meetup. Just save some. If you guys could do a photo, that would be great. Something I'm gonna learn by something that my parents are just right. It's coming. Yeah.
Okay.
Okay. Does everyone complete the feedback form?
Feedback form of?
Still working on that? Still
All
waiting
right.
for
Yeah.
1 more minute?
Yeah.
Yeah. We've just got how many? 21?
Yeah.
Oh, still coming. Yeah. Oh, yeah, sure. Where's the main slide? Main slide. Yeah. Main slide.
Yeah. Here. This one.
One more minute. I will start with our raffle. Okay, so we have 4 t-shirts and 2 what's that?
Purse.
It's pocket.
Pocket pen. Yeah, it's a travel pocket.
Bag, it's tag, and 1 sock.
Yes.
Yeah,
Yes.
from our sponsors. So
Yes.
for today's guest, and just yeah, raffle for 7 takeaways, and the rest of the stickers just feel free to take away after you.
All right.
Yeah. All
Okay.
right. So back to our list. That's the fresh. Okay. Okay. Just copy those names. And
all right.
yeah.
Let's start the fun now.
Yeah.
Yeah, we started first.
Yeah.
Lucky person.
Yeah.
Okay, the first, it goes to Charles. Who's Charles? Oh yeah, congrats. And just feel free come to pick one. Yeah, pick one swag for you. So sorry, I moved to here.
Yeah, I'll just keep.
All right, let's go to.
Okay, I'll just watch.
Would you mind just help him to
Yeah.
just to pick any of you? Yeah.
Thank
Just
you.
to pick any of the one. Yeah, just check size.
What size? Like.
All right, let's go to the
this
next
is,
lucky one.
Love. This is love.
I
Spinning.
should probably get that, but I like this symbol better. So
Yeah.
thank you. Thank you very much.
The next second like persons come to third. Who's third?
Stewart.
Oh, Stu, sorry. Sorry. Congrats. Congrats. Yeah. As the third.
Small. Yeah.
I have third lucky
Cool.
guy. It goes to. Sorry, I couldn't
Vijay.
pronounce the name.
Vijay.
Oh,
Mangraj.
Vijay.
Vijay. Mangraj. Wow.
Congrats. Let's continue to the next one.
And yeah, this. Oh, yeah, here. Yeah, this is. This is medium.
I think it's the Harry. Harry.
Henry.
Congrats. That's Harry.
Cool.
Cool.
So
We have
Henry,
three
you got-
more go
Okay.
to go. Yeah, the last three.
Yeah. Cool. Yeah.
Next one. Andy. Andy Young. Andy.
Andy.
Oh,
Yeah,
congrats,
hi.
Andy.
So you got now 3 options.
The last two.
Socks. Yeah. Shoes. Yeah.
Last
Thank you.
second one
Welcome.
goes to. What's it?
Faisal.
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 Yeah. Thank you.
Faisal.
Congrats, Faisal.
So
Okay, the last person.
yeah, this two travelers like.
Oh,
Yeah.
here's the last lucky.
Yeah.
What?
Welcome.
Bowl.
Yeah, this is
Bowl. Bowl.
Hi.
Oh, congrats. And then congrats for all the person. Only one left. Sorry. And then we have a few ticket speakers. Sorry. So just feel free to take away.
Yeah.
And before that, would you mind? Yeah, sorry, would you mind we just gather together and just take one group photo? Yeah, for the last part, would you mind that we stand over there, just in front of the screen, and take the photo of us? Thank you. Group photo. Can we take a group photo together? Group photo.
Yeah. I put the stickers on the left. Oh, cool. Yeah, that's yeah.
Can we organize people standing over there? Can we take photo?
Yeah.
The group photo over there. We can stand over there. Stand over there. Yeah, let's go move over there. Let's just take group photo for us today's event.
I'll take the photo.
I'll take it. Okay.
It's your time. We can all be in it.
I'm going there.
Thanks, Al. We'll Photoshop you. I can put my face. I can put my face on the
Off the edge, right?
Oh yeah.
Get the webcam open.
You'll be on the back.
Look at two of you. Honestly, that'd be pretty funny.
That'd be pretty cool.
Yeah, jump in.
Please.
Can you fit everybody?
Yeah, I can fit everybody. But if you want, I can see you, but I think you don't want to be on the picture. No? Okay. All right. Have a good smile. Ready? Say Kubernetes. Cool. All good.
There's 3 or 4 of them. So.
Oh yeah, should be good. Did you do the? We hold it down. Yeah, you go out, and then it's like.
Oh no, I didn't.
180.
This.
Oh, you just took 3 or 4.
Yeah, 3 or 4 of them.
Yeah, sure. It was so fast. That's why. Yeah, I believe it took 3 or 4.
Thank you.